Hi, hello, dear students. Welcome to our channel Maths with Panindra. In the earlier videos, we discussed about the common root and properties related to nature of roots of the quadratic equation, which I mentioned here heading. Still, some JEE related concepts I am explaining with some examples. Let us have a discussion. The first point in this, point number 1. So let us consider capital D1 and capital D2 are the discriminants. Be the discriminants. You know that a discriminant means what? B square minus 4AC for the quadratic equation. Discriminant of two given quadratic equations, whatever it is, given quadratic equations. Let us considering that quadratic equations are a1x square plus b1x plus c1 equal to 0 and a2x square plus b2x plus c2 equal to 0. D1, D2 are the discriminant of these two quadratic equations. And the sum of discriminants D1 plus D2 is greater than or equal to 0 whenever the sum of the discriminant of the quadratic equations is greater than or equal to 0. That implies that this is only important property. Then at least one of D1, D2, at least one of D1 and D2 is greater than or equal to 0. Whenever sum of the discriminant is greater than or equal to 0, at least one of D1 and D2 is greater than or equal to 0. In this situation, what we have, at least one of the equations has real roots. This is the important property. I will give one example. Dear students. How they will ask the question related to this property 1. The nature of the roots, the question it is, the nature of the roots of the equations x square plus ax plus b equal to 0 and x square plus cx plus d equal to 0, where a, b, c, d are real numbers. And condition is also there. And AC is equal to 2 times of b plus d. Then options. First option, given equations has real roots. Second option, at least one of the given equations, one of the given equations has real roots. Third one, third property, given equations has no real roots. D, given equations has imaginary roots. See here, the condition based on what is the nature of the roots they are asking. Like this, they will give the question based on the condition AC is equal to 2 times of B plus D. So, we will discuss the answer by taking the help of the above property, this property. So, first D1, D2, what are the quadratic equations here? First quadratic equation, x square plus ax plus b is equal to 0. For this discriminant I am writing d1 is equal to b square minus 4 is in place of b, what value is there? A square minus 4 into 1 into b. So this is d1. Next, what is the second quadratic equation? X square plus cx plus d to 0. So discriminant of the quadratic equation 2 is d2 equal to b square means c square minus 4 into 1 into d. So 4d. d1 d2 is over. Now calculate d1 plus d2, that is equal to a square minus 4b plus c square minus 4d, that is equal to a square plus c square. From these two, minus 4 take common, b plus d. Since we have the condition AC is equal to 2 times of b plus d. So from this b plus d make as a subject. AC by 2 is equal to b plus d. Therefore, a square plus c square minus 4 into AC by 2. So 2 ones are 2 twos are. A square plus c square minus 2ac. This is the expansion of a minus c whole square. Any value square, any value is having the square, it should be greater than or equal to 0. That means it indicates d1 plus d2 is greater than or equal to 0. By using this property, d1 plus d2 is greater than or equal to 0. What is the nature of the roots? At least one of the equations has real roots. So, at least one of the equations has real roots. That's what the answer they are asking. So which option it is? At least one of the given equations has real roots. So B option is the right option. This is the, like this way we are going to use the properties related to nature of the quadratic equations. We will move on to the second property, property number 2. So property 2. So concept and example in this way. This concept especially important for the JEE mains exams. Real, dear students, you remember. Previously we discussed that property 1 is d1 plus d2 is greater than or equal to 0. No? Now I am applying the condition if d1 plus d2 is less than 0, what happens? Then d1 plus d2 is less than 0. At least one of d1, d2, at least one of d1 and d2 is less than 0. So, whenever discriminant is less than 0 means imaginary roots only, no? So, that means at least one of the given equations, one of the given equations has imaginary roots. Imaginary roots. So, for example, I am not giving the question, example only. We'll take the different example. So, consider the quadratic expressions, quadratic equations. X square plus 4x plus 3 equal to 0 and x square plus 2x plus 4 equal to 0. I'll change that. These are the quadratic equations. X square plus 4x plus 3 equal to 0 and x square plus 2x plus 4 equal to 0. For this first quadratic equation, discriminant d1 is equal to b square. B is equal to 4 now. So 16 minus 4 into 1 into 3. So d1 is equal to 16 minus 12 is 4. And d2 is equal to b square. 2 square means 4. Minus 4 into 1 into 4. So d2 is equal to 4 minus 12, that is equal to minus 8. So 4 was the 16, no? 16 minus 12 will come, sorry. So now calculate the value of d1 plus d2 in this case. 4 minus 12, that is equal to minus 8, which is absolutely less than 0. So whenever d1 plus d2 is less than 0, here obviously this condition is also one of the, at least one of d1, d2 is less than 0. Here we got d2 is less than 0 only, no? So at least that implies at least one of the given equations has imaginary roots, So for which equation having imaginary roots we can find by observing x square plus 4x plus 3, we can write as x square plus 3x plus x plus 3. So it doesn't have that imaginary. So this is not correct one. Next, which one is? Obviously x square plus 2x plus 4 equal to 0 only has imaginary roots. Why I here I stop is, we know that here equations it will becomes x plus 1 equal to 0 and x plus 3 equal to 0. No, these roots are not imaginary. So obviously for which equation it will come? For this equation the roots will be imaginary. So the second case is d1 plus d2 is less than 0. We got it. Next, third property, d1 into d2. So the third property is property number 3, d1 d2. That means the product of discriminants is less than 0. In this case, the two equations has real roots, two real roots. We will check whether it is real roots or not. Whenever d1 d2 is that real roots, and sometimes even real and complex also will come. d1 d2 is less than 0. both the equations, quadratic equations has two real and two complex roots. Complex means imaginary. For example, same equations we can take. For example, previously we have taken x square plus 4x plus 3 equal to 0, x square plus 2x plus 4 equal to 0. Previous equations only I have taken. So here d1 I am writing, calculating 16 minus 4 into 3, 16 minus 12 which is equal to 4, d2 is equal to 2 square minus 4 into 4 which is equal to 4 minus 16. So d2 is equal to minus 12. Therefore, according to this property, d1 into d2 is equal to 4 into minus 12 which is equal to minus 48 is less than 0, minus value. Whenever d1 d2 is less than 0, quadratic equations have two real. In the previous question also, these are the real roots. X plus 1 equal to 0 means x is equal to minus 1, x is equal to minus 3. These are the real roots. So anyway here imaginary roots. Imaginary roots means complex numbers. So equal to 0, that implies that given equations, quadratic equations has two real roots, real and two imaginary roots or complex roots. Complex or imaginary roots. So here we proved that d1 d2 is less than 0. Now onwards you remember d1 d2 is less than 0, then we decided the roots less than 0. I hope understand. We will move on to the next property, greater than 0 case. So d1 d2 is greater than 0. For all, no need to give that example, just I am giving property. If d1 d2 is greater than 0, product of discriminants. So d1 d2 greater than 0 means compulsory either d1 is greater than 0 or d2 greater than 0. Either d1 is greater than 0 or d2 greater than 0. So whenever both are greater than 0, here 2 roots, no, total 4 real roots will come. So therefore 4 real roots, both are greater than 0 now. 4 real roots greater than d1 d2 greater than 2 cases are available. This is case 1. In this case 2, d1 d2 is greater than 0. Either d1 is less than 0, d1 less than 0 and d2 is also less than 0. Both are less than. So discriminant both less than values means product is greater than 0 only, no. So in this case, so both the quadratic equation, both the discriminants, so both the quadratic equations, both discriminants are less than 0 means both imaginary roots or complex roots will come, or complex roots. So 4 complex roots, here 2 complex roots, here also 2 complex roots. 4 complex roots will come. 4 complex roots. When it is, whenever d1 d2 is greater than 0, so 4 complex roots, 4 real roots. This you have to remember, dear students. Either this case or this case will possible. Either this or this one. Example is there means that time I will discuss. So last one, fifth property regarding d1 d2 cases. Property number 5. If d1 d2 is equal to 0, suppose if the product of discriminants is equal to 0, here also two categories. d1 d2 is greater than 0 means, see what are the first possibility? d1 is greater than 0 and d2 equal to 0, or d2 is greater than 0 and d1 is equal to 0. So both the possibilities are there. In this case, so both the quadratic equation in d1 is greater than 0 means real roots will come, d2 equal to 0 means equal roots will come. So greater than equal to, greater than equal to, greater than means real and distinct, equal to means real equal roots. So whenever d1 is greater than 0 and d2 equal to 0 or d2 greater than 0 d1 equal to 0, the quadratic equations has two equal real roots, two equal real roots when it is case d1 equal to 0 d2 is equal to 0 case, and two distinct roots also, and two distinct real roots. I hope understand. Not only this case but also d1 dt is equal to 0 means not only greater than 0 but also less than 0 case also possible now. So same category, wherever greater is there, less than I am writing. d1 is less than 0 and d2 is equal to 0, or d2 is less than 0 and d1 is equal to 0. In this case also the product of discriminants is equal to 0, d1 is equal to 0. That implies that quadratic equations d1 is less than 0, d2 is less than 0, imaginary roots. So in these two imaginary roots we are getting d2 equal to 0, d1 equal to 0 means two equal real roots will come. So quadratic equations has two less than 0 means imaginary roots, equal to 0 means real. Two imaginary roots, and two equal roots, two equal real roots, two real equal roots. Anything you can write, equal real roots or real equal real roots. I hope understand, dear students. But these 5 properties you should learn thoroughly. Why? Because we may expect in the JEE Mains exam, any one of the shifts they will ask this type of questions maybe. So some questions I will discuss. I already discussed in the one of the videos, common root concept. So still some questions I want to cover. I am doing. I hope you are enjoying this. So the next question related to the common roots. If the quadratic equation, I am writing in simplest forms for time taking. If the quadratic equation x square plus ax plus b is equal to 0 and x square plus bx plus a equal to 0, where a is not equal to b, have a common root, then the numerical value of a plus b equal to, this type of question, like integer type questions are there now nowadays. So we may expect this type of question, integer type question. See, common root means alpha. I am assuming what are the quadratic equations here? X square plus ax plus b equal to 0 and x square plus bx plus a equal to 0. both the quadratic equations having alpha be the common root. Let alpha be the common root. Let alpha be the common root. So whenever we are assuming common root, it satisfies both the quadratic equation, no? Then we have alpha square plus a alpha plus b equal to 0, and this equation, second equation, alpha square plus b alpha plus a equal to 0. So both the equations having common root, so simultaneously we can subtract both the equations. So alpha square plus a alpha plus b minus alpha square minus b alpha minus a equal to 0 on subtracting. Otherwise you put equation number 1 and equation number 2. On subtracting 1 minus 2, you will get, anyway these two will be cancelled. From these two, alpha we are taking common, a minus b, and minus a we can take this side, plus a minus b. So even a minus b get cancelled, alpha is equal to 1. So alpha is equal to 1, substitute either in equation 1 or equation 2. Therefore, we get 1 square plus a plus b equal to 0. That implies that a plus b is equal to minus 1. Therefore, the numerical value of a plus b is minus 1. So our answer is integer type question. Is minus 1 is the answer, numerical value of a plus b. I hope everyone understand. We'll move on to the next question. This is objective question only, multiple question only. If two equations, here equations in the sense x square plus ax plus bc is equal to 0 and x square plus bx plus ca equal to 0, have a common root, then find the condition, in terms of A, B, C is options A plus B minus C equal to 0. Second option, A minus B plus C equal to 0. Third option, minus A minus B plus C equal to 0. A plus B plus C equal to 0. So which one you are expecting? So common root, and one more, two equations are there, but both are different quadratic equation. In this ax plus bc is there, here bx plus ca is there in this. So both the quadratic equations, first quadratic equation, common root they mentioned here, common root. So x square plus ax plus bc is equal to 0. For this equation, I am assuming that alpha comma beta are the roots of this equation. So whenever alpha beta are the roots, sum of the roots and product of the roots we can write now. Then alpha plus beta is equal to minus b by a. So minus a will come. And product of the roots c by a. So c value is bc, a value is 1. So bc. Till here you understand. So alpha plus beta and alpha beta value, we got it. And what is the second quadratic equation? X square plus bx plus ac is equal to 0. Common root they mentioned now here, common root. So whenever it is common root, alpha, beta, any one of them I am taking here also, alpha and gamma are roots of this equation. Then alpha, gamma are roots of this equation. So here also sum of the roots, product of the roots. Then alpha plus gamma is equal to minus b according to this equation, and alpha gamma is equal to AC. So this information we have, common root. In the earlier classes, in maths 1B, I think it is one of the papers of mathematics in intermediate, cross multiplication method is there. So here alpha is the common root, no? From these two, alpha beta root and alpha gamma root is alpha is the common root. Therefore, both alpha is a common root from this. Alpha is a common root of quadratic equations. So then alpha square plus a alpha plus bc equal to 0, and another equation alpha square plus b alpha plus ac is equal to 0. So both are the quadratic equations. So I am going to solve for alpha square and alpha. Like solving for x and y, one cross multiplication method is there, no? By cross multiplication method, first alpha coefficient you have to write it. Alpha coefficient is by here what? A. Next constant BC. Next alpha square coefficient. Again alpha coefficient. Similarly, in the second equation also, alpha coefficient is B and constant is AC, and alpha square coefficient is 1 and alpha coefficient is B. So in between first two columns alpha square, in next two columns alpha, and here constant. So how to write these values? Alpha square divided by a into AC, a square C minus b square C is equal to alpha by BC minus AC is equal to 1 by B minus A. So alpha square by, here C I am taking common, not only C but also A square minus B square means A minus B into A plus B only, no? So alpha by C take common, B minus A, which is equal to 1 by B minus A. So B minus A, B minus A is there here, A minus B is there. So in the next step, alpha square by minus C into B minus A into A plus B is equal to alpha by C into B minus A is equal to 1 by B minus A. So B minus A, B minus A, B minus A I am cancelling. So remaining alpha square by minus C is equal to alpha by C is equal to 1. Equating these two, you will get alpha is equal to C. Even if you equate these two, alpha square is equal to alpha is equal to C, it is enough. From this only we will get the condition. See how it will come the condition. Here alpha plus beta is equal to minus A, na? Alpha plus beta is equal to minus C. Alpha is equal to C. Alpha is equal to C. So here I forgot to write minus c into a plus b. So equating these two or these two, that is our wish. Alpha square by minus c into a plus b is equal to 1. That implies that alpha square is equal to minus c into a plus b. So alpha is equal to c, substitute here. C square is equal to minus c into a plus b. So c get cancelled. C is equal to minus of a plus b. That minus of a plus b we can take this side now. So complete minus of a plus b can take this side plus a plus b. Already plus c is there. A plus b plus c is equal to 0 now. This is the condition, the relation between a, b, c. A plus b plus c is equal to 0, which is there in the fourth option. Then the condition in terms of a, b, c is, I hope understand, dear students. Alpha is equal to c. By equating anyway these three are equal, we can get it. So one other question based on this real common roots. It's a simple way I will explain. So question number, another question. Again relation between ABC, but it's a good question. If the equation x square plus 3x plus 9 equal to 0 and ax square plus bx plus c equal to 0 have a common root, and a comma b comma c belongs to n natural numbers, then the relation between ABC is, then the relation between a comma b comma c is, first option a, b, c are in AP, second option a, b, c are in GP. You know that how they are asking that options, you can expect easily. A, B, C are in harmonic progression, HP. So A, B, C are in AGP, arithmetic geometric progression. So here two quadratic equations are there in this. One is general quadratic equation, another one is quadratic equation by finding the discriminant. We will say that the nature of the roots of the quadratic equation. See here, x square plus 3x plus 9 equal to 0, and another quadratic equation is ax square plus bx plus c equal to 0. First quadratic equation, second quadratic equation, first one and second one, or second one, first one, anything you can write. Generally what you will write is unknown, that is general equation of that you can write as 1, better to write equation 1. This is equation number 2. But deciding factor is discriminant. So discriminant of the quadratic equation, for this you can calculate, discriminant d or delta is equal to b square minus 4ac. We don't know whether it is greater than 0 or less than 0 or equal to 0, but here we can get it. Delta or d is equal to b square minus 4ac. So b square means 3 square, 9 minus 4 into 1 into 9. So 9 minus 36. obviously less than 0. So discriminant is less than 0. So one of the quadratic equations discriminant or complex numbers, discriminant less than 0 means imaginary or complex numbers. That implies that whenever discriminant is less than 0, one of the quadratic equations, discriminant less than 0, the coefficient of quadratic terms, coefficients of like terms in the given equations. This is important property, dear students, you remember that the coefficients of like terms in the quadratic equations are proportional. So that means this is very important property. Keep in mind, dear students, whenever discriminant is less than 0, the coefficients of like terms in the quadratic equations are in proportional. So in the first equation, x square coefficient is what? A. In the second equation, x square coefficient is what? 1, which is equal to, in the first equation, x coefficient is b, here x coefficient is 3. In this constant c, in this constant 9, they are in proportional. But how we will get the values of ABC? This is equal to some k, I am assuming that, we can assume that. And k is greater than or equal to 1, you can take it. As ABC are in natural numbers now, that is the reason. As A, B, C belongs to natural numbers, that is the reason greater than or equal to 1 I have taken. Otherwise, greater than or equal to 0 also we can write. But I mentioned that ABC are greater than or equal belongs to n. So by equating these, A is equal to 1k, that means k. B is equal to 3 into k, 3k. C is equal to 9k. So we will check that the relation between A, B, C now. So 9k square, so B square, first option verification. ABC are in AP. AP means twice of the middle is equal to sum of the extremities. Twice of the middle. So 2 times of 3k, 6k. Sum of the extremities, k plus 9k is 10k. 10k is not equal to 6k. So first option verification. Option verification I am doing. So first option is not correct. Go to the second option. ABC are in geometrical progression, GP. So ABC are in GP means square of the middle is equal to B square is equal to product of the extremities, no, A into C. So we will check that whether it is correct or not. B square 3k whole square, that is equal to 9k square. A value is k into C value is 9k. 9k into k is 9k square. Both are correct only, no. So B option is the right option. The relation between A, B, C is geometrical progression. I hope everyone understand, dear students. Slowly once again you recollect that. So this is the very important role. This point we keep in mind. In both the quadratic equations, discriminant is less than 0. In one of the discriminant is less than 0. The coefficients of like terms in the quadratic equations are in proportional. Based on this property only we will get the relation between ABC. Now, one important result I am telling. So based on the result, I will explain one question also. This already we discussed, but still I am reminding you, if the sum of coefficients of ax square plus bx plus c equal to 0 is 0, that is a plus b plus c equal to 0, then the roots of the equation are 1 comma c by a, 1 comma c by a. Absolutely. From this, one other point, this is point number 1, point number 2. If a minus b plus c is equal to 0, suppose a minus b plus c equal to 0, then the roots of the equation, roots of ax square plus bx plus c equal to 0 are minus 1 and minus c by a. Minus 1 and minus c by a. That means if a plus b plus c is equal to 0, roots are 1 comma c by a. If a minus b plus c equal to 0, then the roots are minus 1 and minus c by a. You remember, dear students, this is an important case. I will give that one example based on this. Within short trick we will go. The roots of x square minus 2022x plus 2021 is equal to 0, or so this one we can see here. This you have to compare with this quadratic equation. You have to compare with ax square plus bx plus c equal to 0. So here you write the values of ABC. A is equal to 1, B is equal to minus 2022 and C is equal to 2021. Here which one is possible? A plus B plus C, first you verify. 1 minus 2022 plus 2021. So A plus B plus C, 2021 plus 1 is 2022, minus 22, 0. So here A plus B plus C is equal to 0 means what are the roots? Therefore, the roots are 1 comma C by A, that is 1 and C value is what? 2021. A value is 1. So that is the reason I am not writing. By 1, that also we can write as 1 and 2021. So how we are getting easily by the concept of roots are by taking that example, sum of the roots, sum of the coefficients. I hope everyone understand this concept. I have given examples also. So in the next class, different questions we will discuss based on that in quadratic equations only, different JEE Mains type questions. I will explain more 2 to 3 videos. I will and even the position of the critical points and the behavior of the roots, where it will be, whether it is inside the curve, like sign of the quadratic expressions, like I will discuss in the next videos. Thank you, dear students, for watching our channel. Thank you all. And one more important thing, dear students, in the description link my telegram channel is also available. In that, my youtube channel links and any subject related formulas or any material I will provide in that. Please join in that telegram channel also. The channel name is also Maths with Panindra. I will give the link in the description of this video. Please do subscribe, share and support to our channel, not only youtube channel but also telegram. Thank you all. Signing off, Maths with Panindra. Jai Hind.